Okay, so here we are with 6.2 day one. We're looking at solving quadratic equations, or how to solve quadratic equations. So I've gone ahead here and filled in the majority of the handout so that you can pause the video and perhaps just copy some of the advantages and disadvantages. But we can go over them quickly first. Um, what are the advantages? We're just looking at the advantages and disadvantages. Let's highlight this one red maybe as a disadvantage, and we'll make. Let's put this one as green maybe for advantages. And we just want to identify what are the advantages and disadvantages of vertex form. So you should recognize this as vertex form. And the next one is root form. And the last one is standard. So let's fix that up quickly. So when you have vertex form, what's nice about that is that you get to obtain the vertex pretty quickly. When you have vertex form, you can graph that pretty quickly as well, and you can get the y-intercept. How do we get the y-intercept? Simply plugging in 0 for x. That would get us our y-intercept pretty quickly. For root form, uh, I'd say that's even a little easier or more advantageous than vertex form because you can quickly get the roots. You can obtain the vertex because that would be the midpoint between the roots, and you can certainly graph that pretty quickly. And you can easily obtain the y-intercept because you can, again, plug in 0 for x. In standard form, you can identify the y-intercept pretty quickly, but you really can't get the vertex or the root form without having to factor or complete the square. So in this case, the standard form is not easy to graph, and there's not many points that are easily recognizable from the equation. For vertex form, one of the disadvantages you could say are that the roots aren't obvious. So in that case, in order to get the roots, you'd have to first put this in standard form and then factor if possible. In root form, the disadvantages are really not that many, to be honest, apart from having to do some work to obtain other points on the parabola. So from root form, if you wanted the vertex, you'd have to find the midpoint between the roots and then obtain the vertex, or find the x value of the vertex, then sub that in to the equation and solve for y. So a couple more steps to get the vertex there. So again, you might want to pause the video and just copy some of the points there, please. The learning goal for this lesson is to understand that if two factors or roots have a product of 0, and what I mean by that is if you look at the first example, x minus 3 is one root and x plus 4 is another root, and those are factors because they multiply to get a product of 0. So if two factors or roots have a product of 0, then one or more of the factors must be 0. And please understand what it's saying. It's saying if you have x minus 3 being multiplied by x plus 4 and the answer is 0, or the product of those factors is 0, well, the only way to get an answer of 0 is if either x minus 3 is 0 or x plus 4 is 0, or both. Because the only way to get an answer of 0 is if you multiply something by 0. So something times 0 equals 0. So again, either this is 0, or they're both 0. So one of those two, or three, I'd say. One, the other, or both. The next point is to solve by factoring. First, write equations in standard form, and then factor the left side of each, and then set each root to 0 and solve for the unknown. So basically, we want to make sure that the equation is in standard form. We want to factor it because when you factor standard form, you can get root form. And with root form, you can then set each root to 0, meaning make them equal 0, and then solve for the unknown. And what it means is do this. So again, either x minus 3 is 0, so we can say x minus 3 equals 0, or let's put that with a different color so we understand what we're doing, or x plus 4 equals 0. Well, if x minus 3 is 0, and we solved here x equal 3, if you add 3 to both sides, and that would be one root. And if x plus 4 is 0, then x equal negative 4. And it's that simple. Okay, let's look at the next example. We're trying to solve these. So we want to factor them or get them into root form in some way, shape, or form so that we can isolate the variable and solve. Let me just expand this a little bit here to help us out. So remember, when you're factoring, our learning goal said to solve by factoring, first write equations in standard form. Well, this is not quite standard form just yet. You may be thinking, oh, it looks like a perfect square, m squared, but we don't have anything else here. This is equal. What we want to do is we want to have m squared minus 11m equals 0. So we've subtracted 11m from both sides. In this case, we have an a value of 1, a b value of negative 11, and c is 0. We don't have anything for c, so it's 0. In order to do this, we learned that when factoring, we want to always look for the GCF first. What is the greatest common factor between m squared and minus 11m? In this case, our greatest common factor is m. So m times m minus 11 equals 0. Again, if this is equal to 0, then either m is 0 or m minus 11 is 0. One of those two must be 0 for them to multiply and have an answer or a product of 0. So we say m equals 0 or m minus 11 equals 0. If m minus 11 equals 0, then m is equal to 11. So our solution is either 0 or 11. Here, again, we want to put this into standard form. So we have 9x squared. We're going to subtract x from both sides, and we're going to subtract 8 from both sides, and that will equal 0. So we've got it in standard form. It's set to 0, and now we just need to get our roots, so we want to factor this. Is there a greatest common factor between 9 and negative 1 and negative 8? There is not. So what we're going to do here is we're going to try and multiply the 9 times 8 because it's not factorable. There's no greatest common factor, so the next thing we're going to do is look at 9 times 8, or a times c, is negative 72. We're looking for two numbers that multiply to 72 and have a sum of b, which is negative 1. Well, 9 times 8 is 72. So let's use that. If 9 times 8 is 72, and we want a sum of negative 1, we can have a negative 9 times a positive 8. So we rewrite the question, 9x squared minus 9x plus 8x minus 8 equals 0. And you'll remember that we have negative 9x plus 8x. That will give us a negative 1x or negative x. And so we really haven't changed anything. And now we want to factor by grouping. So to do that, we are going to take the greatest common factor between 9x squared and minus 9x. In this case, it's 9x. And then times x minus 1. And then the greatest common factor between 8x and minus 8 is positive 8. And that'll also be x minus 1. In this case, we will write x minus 1 times 9x plus 8 equals 0. And so those are our two roots. So we say either x minus 1 equals 0 or 9x plus 8 equals 0. If x minus 1 is 0, then x equals 1. Or, in this case, we'd have 9x equal negative 8, and then we have to divide both sides by 9 to isolate the x, and then x would equal negative 8 over 9. That one's a little more complicated, but if you're proficient with factoring, then you know exactly what to do to get that into root form. Now here's an interesting question. Write a quadratic equation in the form y equal ax squared plus bx plus c. So we want standard form, and the question's telling us that it wants the roots to be 3 and 7. Well, if we want it in standard form, we can't just simply start writing y equal something x squared and just start placing numbers in. So what we want to do is, if we know our roots are 3 and 7, then let's work backwards here. Let's say y equal x plus x minus 3 and x minus 7. So we know that our roots are, when written like this, x is 3, our roots are positive 3 and positive 7. Okay, in this case, we want it in standard form. In order to get standard form, we have to FOIL, first outside, inside, last, right? So we're going to distribute the x to both and then a negative 3 to the binomial in the second set of brackets. However, we want to have an a value greater than 1 because we have ax squared here. So we can choose any number we'd like. So I'm just going to choose the number 3 just for fun. So we'll have y equal 3 times x minus 3 times x minus 7. And I think the simplest way to do this is to leave the 3 alone. Don't distribute it yet. Of course, you could distribute the 3 times x and 3 times negative 3, and then whatever your answer is there, you can now FOIL that with the x and the negative 7. But I find that a little more complicated. So here's what I'd like to do. I'd say let's just leave it alone, and we're going to FOIL x times x, which is x squared, x times negative 7, which is negative 7x, negative 3 times x, negative 3x, and negative 3 times negative 7 is positive 21. And then what we're going to do is simplify what's in the brackets. We have x squared, and we know negative 7x minus 3x should be negative 10x, and the positive 21 has no other like terms, so it stays like that as a constant. And now we're going to distribute the 3 to every term. So that would be 3 times the x squared, 3 times negative 10x, and 3 times 21. And that leaves us with 3x squared minus 30x plus 63. And now we've written an equation in standard form that we know for sure has the roots 3 and 7. Okay, and that's it for this lesson. So I will see you in class and hope that makes sense.